Hi everyone, it's Paul Tilley and welcome back to Unit 2, Amortization of Loans and Repayment of Mortgages. In this unit, what we're going to do is apply the things that we looked at in Unit 1 to some practical applications. This unit in particular looks at loans and how we pay them off, how we calculate paying them off, how we can predict the payments, and these sorts of things. So that's what we're going to be looking at. We're going to break it into two basic parts. The first part, we're going to talk about loan amortization and loan amortization schedules. And then the second part, we're going to look at residential mortgages and commercial mortgages and how they operate. Not that much different than loans, but we'll do it in two parts. Just in terms of an overview, loans, first of all, are used in business all the time. And they're used by people all the time because basically not everyone has enough resources to buy the things they need immediately. So what you do is you borrow money for it. So these borrowed funds allow us to purchase things and start using them right away. So that new washing machine or that new pickup truck if you own a business, that sort of things can be facilitated by loans. So borrowing money allows us to get use of it right away. And it also allows us to take the funds that we have that we don't tie up in an asset, let's say, for example, that truck, and we can use them in some other way, and probably that way will be more beneficial. So let's say the loan is charging 10%. Well, if we can earn greater than 10% doing something else with the money, it's beneficial to get a loan, buy the truck, and use the other money for other things that earn more return. When we think about interest on loans, the interest is really the rent that the lender charges you in order to use that money. And you're basically paying rent on that money. And as you have the loan longer, you're going to pay more rent. Or as interest rates go up, you're going to pay more rent. These are the sorts of things that we'll look at in this unit. The functionality part of the unit deals with paying off loans. So, it's pretty easy from a point of view to think about, okay, we can go get a loan for $100,000. But how do we figure out what the payment's going to be on it, given an interest rate? How much of that payment is paying down the principal and how much is paying interest. Loan amortization is a process of repaying the loan by equal periodic payments. And again, that's what we talked about as an annuity, right? It's an equal periodic payment. And each payment is really made up of two components. The first component is really the repayment component. How much are we actually paying back on the principal? And the second component is the interest, which is the rent on the money. So as we pay off more of the loan, we're going to see a change in the proportions of how much goes towards principal and how much goes towards rent. When the loan is brand new, you're going to be paying a lot of interest on it in terms of the physical amount of interest as a proportion of the total payment. As you pay the loan off, you're floating less and less money. In other words, there's less principal. So as a result, the proportion of the payment that is actual repayment goes up and the proportion of the payment that is rent goes down. So there's several applications in which we need to separate the principal and the interest out, as I just talked about, and we're going to learn how to do that. Loans can be short-term loans or long-term loans. The only real difference is a short-term loan that tends to have a fixed rate of interest, whereas a long-term loan, the interest rate may vary over time and things will change, as we see with a mortgage type of loan. So we might ask, what makes mortgage loans different than regular loans? Well, a mortgage loan is different in a couple ways. First of all, it's longer termed. And second of all, it is a secured loan. It's secured against a piece of property. So if you buy a house, normally the house itself is security for the loan. So the face value of the mortgage is really the original principal that you borrow. Okay? And that's known as the face value. Now, the most common amortization period for a typical mortgage is about 25 years. You can get shorter and you can get longer, but 25 years tends to be the norm. And that 25 years is broken down into terms. Now, the term really is defined by the type of mortgage you get. Some mortgages have a 1-year term. Some have 2-year terms, 3-year, 4-year, right up to about 7 years. The trick with the term is that during the term, the interest rate is fixed. But every term, the interest rate will be reassessed. So we're going to have a different interest rate as we move through the various terms of a 25-year mortgage. So we need to recalculate the payment every time the term changes. The interest rate on a mortgage is normally stated as an annual rate, 7% interest, for example. But the compounding of a mortgage tends to be semi-annual. So when we think about mortgages and that type of loan, it is a semi-annual compounding. So we know that some mortgages will fall across the year. So we need to be able to estimate how much, or to give a really good estimate of how much we owe on a loan or a mortgage at the end of the year. So for the purposes of the financial statements, we need to say, okay, we owe this much money and we have had this much interest expense. Okay, so the math that we're doing here is really to answer those basic accounting questions. How much do we owe and how much interest expense do we incur? In order to be able to calculate then a term loan, the mechanics of calculating it is we need to be able to figure out what the payment's going to be. That's probably the very first thing that you're going to want to say. Okay, if for example you can go borrow $1,000 and you say, okay, I'm going to pay this $1,000 back over 5 years and I'm going to pay 10% interest rate on it. You might ask yourself, well, what do we pay per month? What, or per year, or depending on what the schedule of repayment is, what are we going to pay? So we need to be able to figure that out. In order to do that, what we use is the present value formula that we've seen. The present value formula for an annuity is PV, and you can see it written there instead of me trying to fuddle through it. So we know that we got to worry about the number of periods, and we know we got to worry about the periodic interest rate because I and the minus n is there. So we're basically going to calculate, if we know the present value is the amount of the loan, and we know the interest, and we know the number of periods, we could be able to calculate PMT, which is the payment. So instead of calculating the present value like we've normally been doing, what we're going to do is calculate the payment. So we've got all the other information except for the payment. So we're going to basically run the formula and calculate PMT based on the information that was given us. So we have to do that. And that is a pretty straightforward thing. If we got all the information, we just plug it into the formula, and voila, out comes the amount of money that we have to pay on the loan. The next thing we need to do for the purposes of the accounting issue, as I mentioned, is we're going to figure out how much interest is really part of this and how much is principal repayment. So the first thing we need to do is determine the interest component of a given payment. We simply do that by taking the periodic interest rate and multiplying it by the balance on the loan. So if we had a loan, for example, of $1,000 and we're making our very first payment, so we say, okay, this is a 5-year loan, 10% interest rate. So $1,000 times 0.10, which is 10% interest rate, says $100. So there's the amount of interest that you have for the first year. Okay, so that would be pretty straightforward to do. We can calculate the periodic interest rate. Using the periodic interest rate and the principal, we can calculate the interest portion. So if we can figure out the interest portion, and we can figure out the payment, well, we know that the payment is made up of an interest portion plus a principal portion. So if we got two of the items, we know what the payment is and we know what the interest is, we can subtract one from the other and we can get how much is paying down on the principal. So we can clearly figure out how we calculate the principal. So the principal portion is simply the payment minus the interest portion. And what we can do for each payment is we can create a table called a loan amortization table that represents that information of how much we have to pay each payment period, how much of that payment is interest, how much of that payment is principal, and what the balance is at the end of the payment period. Okay, so here's basically a typical table and the typical headings that you have on it. You have the payment number. So if you're doing 5 payments on a loan, say a 5-year loan, once a year, $1,000. So we'll have 5 payments. The beginning balance of the principal really is going to be the beginning balance in one period is the end balance of the previous period. So the very first amount that we're going to put in there is the amount of the loan, because that's what we borrowed. Everything else we put in there is going to be what the balance was at the end of the previous period. The payment amount, as I said, we plug in the present value formula. We just plug the information in there and we'll get the PMT. The interest portion is just the principal balance at the beginning of the period, and multiplying it by the periodic interest rate. And the principal portion is just the payment minus the interest portion. And the end balance is simply the beginning balance up at the beginning, less how much you paid on the principal, and that will give you the end balance on the principal. So with that bit of, I'll call it table setup, we can take a typical example. And these slides that I have here just explain exactly the same thing. I just pulled them right from the book. So here, for example, is this example that I've been throwing out for the last little while. The borrow $1,000 for 5 years, one payment per year, 10% annual interest rate. So we know that we have to use this formula right here in order to calculate the payment. So here it is right here. I've got it. I'll just zoom it up. I'll bring it up here just to kind of make it look a little bit bigger for the purposes of this. So in the case of here, we got a present value. We know we borrowed $1,000. That's the present value. We don't know the payment. That's what we're looking for. We know the value I, 10% annual interest rate. That's 0.10. And we know the number of payments. That would be 5 years, one payment a year, 5 payments. So we just put that basic information into this formula. When we do that, we'll get 1,000 equals PMT times 3.791. We take 10,000, take 1,000 divided by 3.9791, and we will get a payment of $263.79, 80 cents, let's say. Let's just round it off. Okay, so there's $263.80. So I'll just slim that back down there. So effectively what's happening here then, what's happening here is that here's the table that I've highlighted up here. Here's the headings. And so payment for year one, the beginning balance was 1,000. We calculated the payment amount over here to be $263.78, 79, 80 cents, around there. Okay? Rounding is going to cause those differences. Don't worry about it. So the payment is that. The interest portion, as I said to you, if you take the beginning principal amount and you multiply it by the interest rate, the relevant periodic interest rate, in this case is a once a year payment, so 10% on once a year is 0.10. So $1,000 times 0.10 is $100. Okay? So then we say, okay, can we figure out the principal portion? Well, the principal portion is simply the $263.78 payment less how much interest we paid, which means that we paid $163.76 on the principal. So in order to get the ending balance sum, we take the $1,000, we subtract off the $163.76, which is the principal portion, and that will give us $836.24 as the ending balance at the end of the period. That ending balance then becomes the beginning balance for the next period. So $836.24, we're going to carry it right down to here. The payment amount is the same every month. Could be different on the last month, but generally it's the same every month. So we just transcribe down $263.78, which is the amount of payment. We know that the interest portion, well, the loan that we borrowed, in year two, there was $836.24 still outstanding. That was going to incur 10% interest, so $83.62 is the interest. We take that interest amount, we subtract it off the payment altogether, and that will give us how much goes towards principal, which is $180. We take that and we subtract it from the beginning balance, the principal amount that we paid. That means we got $656 left. So at the end of year two, we owe $656.08 on the loan. Now, instead of writing out all the mechanics here, I've just put down the quick answers. So we got here, let me go back. Here, this 656.03 becomes the beginning balance in year 3. The $263 would be the payment amount that we've determined. So we'd say, okay, well, what is the interest portion? Well, it's the 656.03 times 10%, which is 65.60. That's where that comes from. Then we say, okay, well, how much was principal? Well, we know we paid this much. This much of it was interest, so 263.80 minus 65.60 is 198.19. Now there are rounding errors here, but effectively brings it down to $188 is how much you pay on the principal. That principal then would get subtracted off the beginning principal, and it will give you a balance of $453.83. The end balance in the previous period becomes the beginning balance in the current period. So there it is right there. The payment is $263. We say, well, how much is the interest, the component? Well, 10% of 45.38 is 45.78, or, you know, again, rounding starts throwing things off here, but generally it's around $45. I'll change that to 38. And then the principal portion is the difference between what you paid less the interest. And there you go. There is this amount right here. Now I'm running in the rounding errors again, and it gets magnified as I go through because I did math on this and I copied down the numbers without putting too many decimal places. So the difference then we paid this much towards principal. This is the payment. That's how much is left. That 239 we owe basically 239 at the beginning of the period. We actually paid 263.80 because there was interest of 23.98. The principal portion then is 215, and basically that brings us down to 0. We pay off the loan after year 5. So this is how these amortization tables work. Normally we would put them into a spreadsheet, as I thought about doing before I put this up here. Now I'm saying to you I should have done it before I put it up here. That way I wouldn't have any rounding errors, or wouldn't have them to the extent that I do. And this table then allows us to calculate our status at any point. So year 1, year 2, year 3, year 4. If someone asks you, how much do we owe on the loan at year 4? $239. How much total interest did we pay after year 4? Well, if we added up the interest, 100 plus 83.62 plus 65.60 will be the total amount of interest that we paid on the loan up until year 3. So we can do a lot of things with this table in order to be able to answer some of the key questions that would be asked by the accounting people with regards to what does our business owe at the current time at the end of the period, or, for example, so that we can reflect a true value of what we owe and what we own in the business and make the financial statements be information rich, we'll call it. Let's assume that we're into a situation where we want to find out the balance on the loan at the 3rd payment period, but we don't want to have we don't have an amortization table. Let's presume that that table is not there, and someone asks you, what's the balance of the loan after the 3rd payment? So we can use one of 2 methods. There are 2 methods, okay? One is called the retrospective method, and the other method is called a prospective method, okay? It sounds more complicated than it actually is. But here is an illustration of the method, okay? Look at the timeline. Here's the timeline along here, okay? And let's assume that you want to know the balance at point number 3, and which is exactly what we want to do here. We want to find out what is the timeline, what is the balance at point number 3. Okay, so how do we do that? Well, if we look at the front end of it, we'll call it the front end here, from 0 to 3. we can use the retrospective method. And what that does is a backward looking, looks at the past to find the future values of a couple of things: the payments themselves and the original amount of the loan. So let's take a look at this retrospective method, okay? The outstanding balance of a loan is the future value of the original debt. So she went and borrowed some money. Monica went and borrowed some money, $1,000 in the case of our example. And we want to know what the balance is at the third payment. Okay, so we're going to use the retrospective method in order to use that. So what the retrospective does is it takes the future value of the original debt minus the future value of the payments made so far. So effectively, we're only looking at this point up to the third year. So in mathematical speak, what I've written here is the formula, but let's turn it into a mathematical formula. Future value of the original debt is calculated using the future value formula, which is PV bracket 1 plus I to the n. That's that part. Minus, there's the minus sign, the future value of the payments made so far. So the payments made so far is the present value, the future value formula for a series of payments, which is right here, PMT 1 plus I to the n minus 1 over I. Okay? So what we're doing is we're using two of these formulas, this one minus this one, in order to calculate the value at year 3. So let's take a look. Here's the retrospective method. Here's the formula, same thing. But let's pull out some of the data. The loan was $1,000. The payment was $174.03 based on our calculation of the payment that we did earlier on. The number of periods that we're talking about is 3. We're at the end of the third period. The interest rate, according to the original problem for Monica, problem was 15% per year, 12 compounds a year monthly, basically. So what we've got is this, the interest rate, the periodic interest rate is 15 divided by 12, which is 0.0125 in decimal format, okay? Which is what we need for the formula. So what we're going to do is take this bit of stuff here, and we're going to plug it into these formulas. So what I've done down here is I've plugged it into the formula. So we got 1,000 bracket 1 plus 0.0125 to the power of n, which is 3. There's this. Minus the payment, 174.03 times 1 plus 0.0125 to the power of 3 minus 1 divided by 0.0125. If you did the math on that, which I've done, if you did the math on these formulas, you would get 1037.97 minus 528.64. This one here is 1037.97. This one here is 528.64. 1003.97 minus 528.64 is $509.33. So effectively, what this retrospective method has done is calculated the balance of the loan at the third period. Now let's just check to make sure that was right. Well, according to our table, our amortization table, hey, what do you know? Same number, 509.32. So effectively, we don't have to do this table if we can use this retrospective method. Okay, fair enough. So that's really all there is to it. Now, easy for me to say, you need to do some examples of this in order to really get a good handle on it, okay? Because it sounds easier than it actually is. You got to plug the numbers in, figure out the numbers and these sorts of things. But this is the mechanics of how it works. You've got to take the present value of the original amount of how much was borrowed effectively, and then, or the future value of the original amount, and the future value of the stream. So we would take one, subtract the other, and way to go. That's the retrospective method. Now, as I said at the beginning, there are two methods. There's the retrospective method for calculating how much is owed, but there's also something called a perspective method. The perspective method is a forward-looking, looks into the future, and uses present value formula. Now, the perspective method is easier. The mechanics of calculating it are easier, but it does exactly the same thing. let's go take a look at the perspective method. So again, exact same problem, okay? We're looking for how much Monica owes at the 3rd year. So what we need to do is we need to say, okay, well, what do we got to use here? The present value of the outstanding payments. So let's calculate the present value of the outstanding payments. That is, how many more payments after year 3? And really, if we think about a loan, what you owe after you've made that last payment, what remains to be owed, what the string of payments that you are obliged to pay into the future. In this case, for example, Monica has paid 3 years of her payments. She has 2 more to do. So the future value of those future payments, if we were to take the present value of those future payments, we should come up with how much is owing on the loan. So effectively, we're going to take the present value equals PMT 1 minus 1 plus I minus N over I. So let's take the math of that. So again, we've got our loan is $1,000. That's the present value. The payment was $174.03. We've calculated that. We're into the 3rd payment. We want to know what was the 3rd payment, and again, the interest. So what we're going to do is plug the numbers into this. So the present value is the payment, $174.03, times 1 minus 1 plus 0.0125 to the minus 3 over 0.0125. We do the math on that, and we get 174.03 times 2.9266. This will give you 2.9266. Multiply those together. What do you know? 509.33. So effectively, what that's done is it's found the value of the amount that was owing after the 3rd payment. And let's check it against the table. Yeah, exactly the same amount. So effectively, the perspective method just takes the string of payments that are remaining to be paid, brings them back to what are they worth now. Okay, so it takes that present value. So the perspective method and the retrospective method do exactly the same thing. It's 2 formulas. You don't have to use both of them. You only need to use one, really. So we really got 3 ways now to figure it out. We can use the amortization table, we can use the retrospective method, or we can use the perspective method to find out how much is owing at any given point in time. Okay, so that's effectively what we're dealing with there, is trying to get a good handle on that. Any questions? I'll just do a couple more little examples here, and then we'll look at an example. Okay. So here is an example using the retrospective method, and this is a full problem. I've just taken it right from the book. This is in your textbook. A $57,000. Let me put on my glasses because I can't see. $57,000 mortgage loan at 6.9% compounded monthly, requires monthly payments during its 20-year amortization period. So the good thing is we look at this, and that's a monthly compounding and a monthly amortization period. So that's good. That's a simple annuity. Way to go. So calculate the monthly payment, round it to the nearest cent, and calculate the balance after 5 years. Okay, so first thing we need to do is find the payment. In order to find the payment, we just use the present value formula, as I've said. So there it is. We are looking for PMT, so we've got all the other information. Present value is $57,000. The interest is 6.9% compounded as the annual, but it's compounded monthly, so we've got to take that divided by 12. That comes out to 0.575%, or 0.00575 as a decimal per month. And the total number we want to find out after 5 years. So we gotta take a look there. Oh, we'll get down to that. So this is a 20-year loan. So 20-year, 12 times 20 would be the total length of the loan. 12 times 20 is 240. We plug all that into the formula as we've done here. The PMT, the payment, will come out as $438.51. Okay, so that's effectively how you calculate payment. Should be pretty straightforward. Just plug that in there. Now, We're asked to calculate the balance after 5 years using the retrospective method. So 5 years now, we're dealing with months here. So 5 years is really 60 months, or the 60th payment. We want to find out what is the value of the loan at the 60th payment, okay? So what we do is we're going to use the retrospective method. And as you recall, the retrospective method takes the future value of the original amount, $57,000, and subtracts the future value of the series of payments that were used up to that point in time. So the future value calculation, here's PV 1 plus I to the power of n. We've taken 57,000. We've put 1.00575. 0.00575 is the interest rate to the n, which is 60 months. So that's the first bit. The second bit looks at the string of payments. So we're saying it was $438.51 was the payment. We run the rest of the numbers in there, and we will get a total of $80,403.94 for this first part, and $31,313 for the second part. 80 minus the 31 comes to $49,090. So effectively what we're saying is that after 5 years, or 60 months, there will be $49,090.86 remaining on that loan. So that's effectively how that is done using the retrospective method. Using the prospective method, and keep in mind now when we think about the prospective method, what we're looking for is just a simple calculation here where we're going to take all of the payments that are made after the 60th payment and bring them back to find the present value of them. So we use this formula right here. We plug the numbers into that formula, and we get $49,090. Notice, same.